So I betcha this is where that 0.07 comes from. 2x squared minus 1 equals 0. Add 1, add 1. 2x squared equals 1. Divide by 2, divide by 2. X squared equals a half. And then, boop, square root, square root. Guess what the square root of 1/2 is? About plus or minus 0.707. Isn't that interesting? And that's where we get those irrational zeros. All right, so hopefully that's going to be okay for you for number 5. That's kind of the example problem that goes along with that. I'm going to journey on to number 6. It's kind of in the same token, right? I'm trying to decide, or I think they tell you that they give you a linear factor and they say, show that this is indeed a factor of this function. All right, so it's set up to group. Notice if I try to group, boom, 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 boom. Here I have a 5x squared in common, and that gives me an x plus 2. Here I have a -1 in common, that gives me an x plus 2. And then if I group, I get x plus 2 times this factor, 5x squared minus 1. So that's excellent. This is showing me that x plus 2 is indeed a factor of this function because I'm able to write it into factored form. Okay, here's the problem. Not all functions factor using grouping. So here is an example of a quad term function. So 5x cubed plus 13x squared plus 7x plus 2. And if I attempt to use the strategy of grouping, so I'm going to do that first. Let's see. No common number. There is an x squared. I get 5x plus 13. And then here, let's see, 1, 7x plus 2. Notice how I don't have a common factor. So grouping, that strategy of grouping, does not work for this function. So we needed a new one. So I'm not sure how much of synthetic division I showed to you. I think I did. I think you were here for synthetic division because that was this last chapter. But I'm going to use synthetic division to be able to see if this works. If synthetic division is kind of problematic, definitely search some YouTube videos on synthetic division. They have excellent ones on YouTube. But the idea for synthetic division, exactly what it sounds like. It's like fake. It feels like fake math. But it's a way of dividing polynomials. So remember, if this times this equals my original function, then my original function divided by 5x squared minus 1 should equal to x plus 2. And vice versa. This function divided by x plus 2 should give me this. So I'm going to divide out my x plus 2 synthetically. So watch what that looks like. I put my solution to that portion of my function in a box. So this is x plus 2. And then I write out the coefficients that I see in my function. So 5, 13, 7, and 2. And then I bring down the first term. So I bring down that first number, which is a 5. And then it becomes a series of multiplication and addition. So watch, multiply, -10, add 3. Multiply, -6, add 1. Multiply, -2, add 0. This is what we call a remainder. And I don't have a remainder to this division of these two polynomials. What I have is, if I multiply x times a 5x squared, that's going to give me my 5x cubed. And then what happens is the other terms are really just the coefficients that you see here. So if I were to multiply 5x squared plus 3x plus 1 times an x plus 2, it's actually to multiply all of this out, I would get out 5x cubed plus 13x squared plus 7x plus 2. And And Julia, you know what? I have a video on dividing polynomials using this idea of a box method. I'm going to send that to you in email as well. All right, so that's for number 6. And then the last one, which is number 7, I'm going to pull that up here. Give me a second. Okay. I'm going to ask you to actually attempt this one on your own. Thinking about what we talked about with a degree of 4, what do you know about your function? Okay, so we were talking about this idea of real and imaginary. I want to take a look at, before I leave you, I want to take a look at this function that we created here. G of x equals 5x cubed plus 13x squared plus 7x plus 2. Remember how I talked to you about how Desmos is like a gateway into understanding functions? So we have 5x, this is to the third. I know it's a little unclear. Give me 1 second. Plus 13x squared plus 7x plus 2. Okay. Let's take a look at that. All right, so this is a cubic function. The idea is if it's a cubic function, it should have 3 solutions. Now, the idea is that imaginary solutions always come in pairs. And that's because we develop imaginary numbers when we take square roots of negative values, right? The square root of -4 is plus or minus 2i. You get a positive 2i and a negative 2i. So imaginary solutions always come in pairs. So I should stand to have 3 solutions to this, but I want you to take a look at the graph. Notice how there's really only one x-intercept. That means there's only one real solution, and it's at -2. That's what I would expect. Look at when I wrote it in factored form. Oh, woo, woo, there it is, x plus 2. That must be a solution that is a -2. But if I were to try to figure out what the solutions are to this function, I would find out using either quadratic formula or trying to factor it or anything like that. I would find out that there are no real solutions. And that's why I get 2 imaginary. So somewhere in this graph, in a faraway land, there are 2 lingering imaginary solutions. Where they're at, I don't know. But that's the concept in this, is that we have 1 real solution, 2 imaginary, and that's how I'm able to get 3 solutions to this function. So hopefully